Welcome everyone! Let's dive right into this because we've got a lot of ground to cover. If you are preparing for your Cambridge Computer Science exams, specifically focusing on the 9618 AS and A level, but honestly, even if you're building your foundation in the 0417, 0478, 0983, 0984, or 2210 syllabus codes, you already know there are certain topics that just consistently trip candidates up. Look, according to senior examiners, taking a structured English description and translating it into working, efficient pseudocode is arguably one of the absolute most misunderstood areas in the entire syllabus. It's like a giant puzzle, and it's a hurdle that catches so many students totally off guard year after year. To really understand why, let's imagine two very typical students taking this exam. We'll call them Alex and Sam. Now, Alex is the kind of student who overloads every single answer with raw computer science facts. They know the textbook inside out, but they offer zero actual analysis. Then you have Sam. Sam just completely rushes through the paper, panics at the sight of structured English, and totally misses the specific command word requirements. They both end up with a page covered in the examiner's red pen marks. But today, we are going to fix that. In this explainer, we are stepping into the shoes of the grader. We're putting on the examiner's lens. We are going to break down exactly what the assessors are looking for, how to structure your thinking so you don't make the mistakes Alex and Sam make, and most importantly, how to capture those elusive top marks. Perfect form and execution, where every single sentence you write is a graceful landing. Let's get into it.
Here is our roadmap for the explainer today. We are going to tackle the pseudocode challenge, core analytical principles, the technical methodology, the top 3 examiner warnings, and finally, your final exam strategy.
Section 1, the pseudocode challenge.
So, why is evaluating algorithm efficiency so unbelievably hard? It's a rhetorical question, but it's one senior examiners ask themselves constantly when marking papers. The difficulty doesn't actually lie in writing the basic code itself. Any student can memorize how to write a for loop or an if statement. The real challenge is that the Cambridge syllabus requires top-performing candidates to exhibit a deeply connected conceptual understanding. You can't just memorize a syntax rule and expect an A-star. You have to take a paragraph of structured English instructions, which might be describing a complex inventory system or a temperature array, and mentally translate that into a highly logical, efficient algorithm. And not just any algorithm, but one that can be evaluated and seamlessly transferred to completely unfamiliar contexts. Think back to our student Alex. Alex tries to answer this by just brain dumping everything they know about iteration and selection. But that doesn't answer the specific question. And Sam? Sam reads the word evaluate, but just writes down what the code does, completely ignoring the command word's demand to weigh the pros and cons. That leap from merely reading English to designing and critiquing an efficient algorithmic structure is exactly where the challenge lies, and it's where the grade boundaries are decided.
Section 2, core analytical principles.
Okay, the absolute crucial point you need to understand here is the method mark strategy. I really want you to internalize this definition because it is a total game changer. The method mark strategy is an assessment framework where marks are awarded for demonstrating systematic analysis and logical process rather than just delivering the final correct answer. Let that sink in for a second. This should actually be a massive relief for you. The examiners are literally telling us that your logical reasoning, your step-by-step breakdown, and your evidence-based process are just as important, sometimes even more important, than a flawless, perfectly syntactical final block of pseudocode. They want to see exactly how your brain is working to deconstruct the problem. If you mess up a variable name at the end, but your logic was sound, you are still picking up the lion's share of the points. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
And this brings us directly to a stark contrast in how students approach the exam: superficial breadth versus analytical depth. Remember our student Alex? Alex goes for superficial breadth. Average candidates will often try to show off absolutely everything they know about programming in a single answer box. They'll throw in nested loops, 2D arrays, file handling concepts, just randomly hoping something sticks and catches the examiner's eye. But that is superficial breadth, and examiners see right through it. The Cambridge Assessment Framework strictly prioritizes analytical depth. What top-tier candidates do is use a structured framework. They often use something like the PEAL framework: point, evidence, explanation, link. They make a clear point about the algorithmic logic. They provide evidence from the structured English given in the prompt. They explain why their chosen data structure is optimal, and they link it back to the overall efficiency of the solution. They take a single, highly focused path and demonstrate deep, systematic analysis of the specific problem sitting right in front of them. Make no mistake, depth will beat breadth every single time in these exams.
Section 3, the technical methodology.
So, how do we actually transform an answer from a failing grade into a top-tier mark? We use a concrete procedural framework. There are 4 essential steps of algorithmic thinking required for this syllabus. Step 1 is step-by-step decomposition. You literally take that block of structured English and break it down into its absolute smallest logical parts. You identify the inputs, the processes, and the outputs. Step 2 is appropriate data structure selection. You have to choose the exact right tools for the job. Do you need a 1D array, a record, a simple Boolean variable? Selecting the wrong structure here causes a domino effect of lost marks. Step 3 is the actual efficient code implementation. This is where you write the pseudocode clearly, ensuring your loops are properly structured and your variables are correctly initialized. And step 4 is rigorous testing. You evaluate its performance, perhaps mentally running a trace table to check your logic. This complete deconstruct, solve, and evaluate cycle is your absolute blueprint. It's the engine for solving literally any practical application question they can throw at you. Imagine watching those red pen marks on Sam and Alex's papers magically transforming into green check marks just by applying this exact sequence.
Now, often in these higher-level papers, you aren't just writing code from scratch. You are asked to evaluate alternative algorithms and make justified recommendations. For these higher-order assessment objectives, you absolutely need comparative analysis. And there are rules for this. First, you must identify both similarities and differences. Don't just tell me how 2 algorithms are different, tell me what they share. Second, you need to use comparative connectives to seamlessly link your thoughts, words like whereas, conversely, or similarly. Third, you have to support every single comparison with hard evidence extracted straight from the data provided. And finally, you must draw conclusions about their relative importance to the specific scenario. If you just list facts about 2 different algorithms without actually comparing them using this peel-like structure, you are leaving precious, easy marks on the table. Stop scrolling, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Top 3 examiner warnings.
I want you to consider this next segment an exclusive insider warning straight from the principal examiner reports. We're going to treat this like a quick interactive workshop. I want you to think about where students lose the most marks. Mistake number 1. Answers are simply too vague. Examiners despise generalizations. They don't want to hear a loop makes it faster. They want specific technical details and evidence-based reasoning. Like, a while loop is more efficient here because the number of iterations is unknown. Mistake number 2. Forgetting to check boundary conditions and edge cases. When you are doing your rigorous testing or writing your code, you absolutely must account for the extremes. Did you use a greater than sign when you actually needed a greater than or equal to sign? That tiny flaw costs marks. And mistake number 3, which honestly we see all the time, answers are not specific to the context given in the question. It's so common, it actually leads perfectly into our next point.
That third mistake is so incredibly critical, it needs its own massive spotlight. Always link every point to the given scenario. If we were doing a speed writing challenge right now and you had 30 seconds to write a perfect paragraph, this is the rule that would make or break you. This is the ultimate classic mistake. You could write the most beautifully efficient, logically flawless algorithm in the world, but if it is a generic, textbook answer that doesn't use the specific variables, the precise data types, or the unique context provided in the examination question, you are going to lose marks. 0 points for the application. You must completely ground your analytical depth in the specific real-world scenario they have handed you on that page. No exceptions.
Section 5. Final exam strategy.
All right, let's pull all of this together. Here is your winning exam strategy, step by step. I want you to memorize this sequence because this is your cheat sheet. First, deconstruct the question. Decode those command words instantly. Second, extract the relevant data. Pull out the specific conditions, the array sizes, and the constraints. Third, select your analytical framework and data structures. This is where your PEL framework application comes in perfectly. Fourth, execute your solution with clear, highly accurate pseudocode notation. And fifth, present everything with the correct technical terminology, ensuring you've managed your time properly, checked for reasonableness, and fully justified any recommendations you've made. If you follow this exact workflow, you are demonstrating the absolute peak of systematic analysis that the method mark strategy is designed to reward. You are basically handing the examiner a map, showing them exactly why you deserve an A star.
And that wraps up our deep dive into translating structured English into pseudocode. Remember, true mastery only comes from actively applying these frameworks to real scenarios. Practice these steps using past paper questions to build your confidence and ensure your answers are always contextualized and specific. But before you sit down to take your next practice paper, I want you to ask yourself a serious question. Are you just writing code hoping to make it work? Or are you purposely designing an algorithm to prove exactly how you think? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.